Listen-only mode.
Good evening, everyone. Welcome to the RSES Manufacturer Webinar Series. I'm Lori Schiavo, RSES Journal publisher and editor. I'd like to welcome everyone to tonight's session on natural refrigerants, which is being presented by Denny Martin. Before we get started, I want to thank Embraco for sponsoring tonight's webinar. Their generous support is how we keep webinars free for members, and we value their shared commitment to educating HVACR professionals. Tonight, a handout has been shared by Embraco, which you can find in the dialog box on the right-hand side of your screen. If you click on it, you'll have the ability to open it and save it to your computer. Please feel free to access it anytime during the webinar. Denny's presentation will last approximately 45 minutes, and afterward there will be a Q&A session. Please submit any questions you have throughout the presentation using the GoToWebinar dialog box, which is on the right-hand side of your screen. I'll field the questions and ask them aloud to Denny. Tonight's presentation is being recorded and will be available online for viewing at your convenience as soon as possible. And now I'd like to introduce our presenter for the evening, Denny Martin.
All right. Good evening, everyone.
That's perfect, Denny.
All right. I want to say, first of all, on behalf of Embraco and myself, thanks for attending the training tonight. We appreciate you taking time out of your busy schedule. My name is Denny Martin. I am the Aftermarket Technical Support Specialist and Aftermarket Product Line Manager for Embraco North America. And if you see anything tonight in the presentation, if you have any questions or concerns, feel free to contact me at this email address, denny.martin@embraco.com. And anything you still have questions about, don't hesitate to contact me. And welcome to Natural Refrigerants Training presented by Embraco. This is the agenda for tonight's presentation. We're going to go over the new legislation that's right around the corner. Why natural refrigerants? Go over some safety and practical items. We're going to go over a compressor replacement overview pertaining to R290 specifically. And then we have the link to the video of changing out an R290 compressor and some recommended reading with a website. And also, then we'll have questions. So new legislation on commercial systems that's right around the corner. We have, starting as soon as 2019-2020, for new and retrofit vending machines and retail food refrigeration, the current refrigerants that we're using in this equipment, the EPA is going to ban these refrigerants. The 507A, 404A, all the 407s, A, C, and F, and 134A. All of these are going to be banned. So the current status of the commercial refrigerant in the U.S., as you can see, here we have a, I need to get this off my screen here so I can see. No, I don't want to do that. Anyway, well, you can see on the right side system the timeline ban for supermarket systems. Let's see if I can minimize this here. There we go. So these bans starting as early as January 1st, 2017 for supermarket systems, all those aforementioned refrigerants will be banned. Now 134A will be excluded from this ban. And then January 1st, 2018 for remote condensing units, all those refrigerants will be banned. And again, 134A will be excluded from this ban. But by January 1st, 2019, all standalone retail units, medium temperature, less than 2,200 BTUs will observe the ban. And then by January 1st, 2020, those standalone units, medium temperature above, equal to or above 2,200 BTUs will observe the ban. And then all standalone retail units that are low temperature, those refrigerants will be banned by January 1st, 2020, and all vending machines in 2019. So for some odd reason, I have these things on my screen. Okay, so, all right, so the current replacements, under the EPA final rule for new equipment for 134A, we have R450A, R513A, the HFO blend 1234YF, and R600A isobutane. For 404A, we have 448A, 449A, and R290 propane. And some of these are already in production, as you can see. The isobutane already in production, the 1234YF, and the R290 propane. So going over again, for medium temp, the approved gases will be 450A, 513A, 1234YF, R600A isobutane, and R290 propane. For low temp applications, the approved gases will be R290, 448A, 449A, and R600. Now 513A and 450A have a bit of an energy penalty versus 134A, which could be possibly offset with changes to the equipment by the OEMs. 448A and 449A have high discharge temperatures, and these could be offset with liquid injection and other means in larger systems. And for more information, you can visit the www.epa.gov/SNAP for more information, because there is a few more refrigerants under the ban if you want to study up more on that. All right, so these pending 2017 DOE energy standards right around the corner for commercial appliances are going to pressure the OEMs to reach new limits of efficiency. So how difficult can some of these standards be in some applications, you might ask? Well, in a horizontal solid door ice cream freezer, you could possibly be looking at up to 53% less energy consumption than the current standard, which is the 2010 DOE energy standard. Let's see here. For some odd reason, I still can't get this off my screen.
Are you trying to get the control bar off, Denny?
Yes, yes, I can't get it off my screen.
There's an arrow that goes left or right at the top. It's a red arrow.
Okay, I see it now. There we go. All right, so for upright glass door freezers, up to possibly 57% less energy consumption than the current standard. Bottle coolers, up to 48% less energy consumption. Professional kitchen equipment, up to 50% less energy consumption. So this is quite significant when you consider the size of some of this equipment in the professional kitchens. So what this means is just changing the compressors, it's not going to be enough to meet these standards. The choice of refrigerant has a tremendous impact on the energy consumption of a system. OEMs are going to have to look at the cabinet design, things like ECM fan motors, LED lights, the wall thickness, the gasketing, and things like this. They're going to have to scrutinize to meet these standards. So this brings us to the question of why natural refrigerants? Well, there's several reasons. One, they have a very low global warming potential rating. Compared to the HFCs and the HCFCs, as you can see, 404As all the way up there at 3750, 1700 for R22, 1300 for 134A, and the natural refrigerants R290 propane and R600A isobutane all the way down there at 3. So very low GWP ratings. And they're very energy efficient. Embraco took this medium glass door merchandiser, it's a freezer, and in 2012 it represented 1 million units in the US. Just by changing from 404A to R290 propane and using LED lights and ECM fan motors, they were able to achieve a 32% reduction in energy consumption. So, and that works out to be about $38 per unit, and with 1 million of them in service, that's $38 million per year. Also took 2,200, would take 2,200 tons of CO2 out of the atmosphere in 10 years. So quite significant, the energy reduction just from these simple changes. You can imagine once the OEMs start to refine their equipment design, what type of energy efficiency they're going to be able to achieve. So natural refrigerants, they are safe as well. Most household and light commercial applications refrigerant charge are equivalent to only 2 or 3 cigarette lighters. And hydrocarbon refrigerants have been used in Europe since about 2003. And the charge limit for natural refrigerants in the U.S. has been set at 150 grams or 5.3 ounces. So for comparison, there's a 20-pound propane tank sitting under your barbecue grill right now, about 8 inches from the burners. So with a small refrigerant charge, they are safe. A few additional benefits. You have lower operating temperatures compared to 404A. As you can see, 404A, the shell temperature is up around 140 degrees, you know, around 100, a little bit higher for the HFO blends, and we're all the way down at about 112 degrees shell temperature for the R290 propane. The discharge temperature as well is lower. We're up around 200 degrees or more with 404A and the HFO blends, and all the way down to 167 degrees with the R290. So lower operating temperatures, so lower shell temperature, lower discharge should equal a longer compressor life. So we also have the benefit of a reduction of refrigerant charge. As compared to 404A, as you can see, to R290, you could have a 45 to 50% reduction of charge with the same capacity. 134A to isobutane, 35 to 40% reduction, and from 134A to R290, 45 to 50% reduction. And once the refrigeration grade hydrocarbon refrigerants become more prevalent, equipment and service costs could be reduced, along with the mitigation of the safety risk due to the small charge. So what makes a refrigeration grade hydrocarbon? Well, it has a high level of purity and a low level of moisture or other contaminants. Now the odorant is removed because this is considered a contaminant. And we want to look for proper labeling to ensure that the gas can be used in a refrigeration system. For example, refrigeration grade propane should be labeled R290 and should not have a blue rhino in the tank. Let's save that one for the burgers. This brings us to our first poll question.
Okay, Denny, I'll go ahead and get that first one launched. And the question is, the 2017 DOE standards can be up to how much more efficient than the current standard? Is it A, 15%, B, 25%, or C, 50%? If you want to go ahead and cast your votes. Okay, I'm going to give it a couple more seconds here. Okay, so it looks like majority of everybody have voted, so I'm going to go ahead and close this out. And I will share the results. The correct answer was C, 50%. Denny, 79% of them answered that correctly. Next, excellent. It was 16% answered B and 4% answered A.
That's right. Let that sink in for a while. They're going to be asking for this equipment to use half of the energy that they're currently using. So it's going to be a big deal. OEMs are going to have to really work really hard at achieving this. So in the light commercial applications with the 150 gram or 5.3 ounce charge limit, the natural refrigerants, R290 propane and R600A isobutane, already can cover most light commercial applications. And multiple circuits could be used for equipment requiring more than 5.3 ounces of R290. So one thing to note, the R600 is going to be more for the smaller systems, the domestic systems. The R290 will be for the medium to larger commercial systems. Like I say, they can use multiple circuits, but time will tell if this is going to be cost effective for the OEMs to do that. So now on to safety and practical. So good old common sense and staying alert is going to go a long way towards working safely with flammable refrigerants. We want to develop work procedures that keep in mind the flammable nature of natural refrigerants and follow them on every job. So hydrocarbon refrigerants, they do not have an odorant, so leaks cannot be identified by smell. So this makes the need for a quality combustible gas leak detector mandatory for hydrocarbon service work. So just a suggestion, I would say do some research and buy the best combustible gas detector that you can afford. It's going to be a very important tool for a technician. And then it's also a good idea to use this detector and pass it through every work site that a technician goes into. Some illegal refrigerants have crossed the border and could have been installed in equipment in excess of the current flammable gas charge limit. You can imagine you get some flammable refrigerant put into a larger AC systems or refrigeration system to the tune of 6 or 7 pounds, and you've got a leak in a small mechanical room, and you can't smell that leak. Very important. Go ahead and pull out that gas detector and sweep the area. Keep yourself safe. So this is just a slide on the safety classification of the refrigerants. You have the flammability classes. Class 1, no flame propagation. Class 2 is low flammability, and Class 3 is high. And then you have Class A and B. Class A is low toxicity. Class B is high toxicity. Natural refrigerants are going to fall under A3 classification, so they're not toxic, but of course they are flammable. Something we definitely need to mention in this presentation. So this slide talks a little bit about the flammability threshold of the natural refrigerants. Without going too much into these numbers that you see up here, the takeaway is the lower explosion limit is 2% of hydrocarbons in the air by volume. So this is the lower limit. The upper explosion limit is 8 to 9% in air by volume. So this is the upper limit. So these hydrocarbon detectors are generally designed to alarm at or below the lower explosion limit for added safety by giving an early warning before the upper explosion limit is reached. Another reason to have a good HC detector. And again, never use a charge over 150 grams or 5.3 ounces as required by the current safety standards. So these are the IEC standards set forth for household appliances and commercial applications. This is basically talking about the charge limit again. And basically both these standards are the same. The charge limit is 150 grams. And that's for each separate refrigeration circuit. And there's no restrictions in room size and occupancy category. So these are the IEC safety standards for electrical appliances. The first one, the 679-0, is the general requirements for the equipment, and 679-15 is for the components in the system, and just stating that these components need to be sealed for explosive gas atmospheres. And for more information on these equipment and parts requirements, you can simply look at these two standards online. IEC 679-0 for the equipment and 679-15 for the parts, the components. So more on the safety standards for the electrical components. Embraco compressors designed for use with hydrocarbons are equipped with electrical components that comply with the EN 679-15 requirements, stating that they are encapsulated or fire and explosion proof. So as an example, we don't want to see these open type overload protectors where you could possibly get a spark out of that device. We want to see the seal type, the 3/4 round with the seal with a cap on it, or the 4TM type, which is considered sealed. So a little bit of information about R290 system components. The system must have a refrigerant identification and risk of fire label, something similar to this. The condenser is basically going to be the same as 404A or 134A system, or it could be slightly smaller because of the efficiency of the natural refrigerants. The evaporator is basically going to be the same as 404A and 134A. In the case of a roll bond evaporator, we do not want to use R290. The design of this evaporator is basically made for lower evaporating pressures, as in 134A systems and isobutane R600A systems. But R290 has a bit higher evaporating pressures, and this design could be more prone to leakage, so we don't want to use those. The piping is going to be the same basically as a 404A system. Filter dryers the same as 404A and 134A. The cap tubes are going to be the same as 404A and 134A, or could possibly, in some applications, be slightly longer, 10 or 15% longer. Expansion valves need to be specific to R290, and heat exchangers with smaller channels could be used to help minimize the refrigerant charge even more under the 150 gram charge limit. So micro-channel heat exchangers could help well, could do well in the design of a system to reduce that charge even more. The fan motors need to be spark-free. The shaded pole type or the ECM electronically commutated motors. Those are what you need to use for the fan motors. The fan blades should be plastic or aluminum. Aluminum is less prone to electrostatic discharge than the steel fan blades. And the other electrical components, stated previously, need to be approved according to the IEC 679-15 standard. So they need to be sealed. A little bit about the lubricants for R290. R290 is totally miscible with polyester. It mixes well with all three basically types of oils: polyester, mineral, and alkybenzene. Embraco out of Europe made some R290 models with POE oil, and Brazil made some models with POE and alkybenzene oil. But the polyester is the recommended option for its biodegradability and good viscosity at high temperature. And it's probably going to end up being the only oil used for R290 moving forward. So some general precautions for service for the workplace. We always want to conduct a risk assessment to determine whether it is appropriate to use a flammable refrigerant in that particular workplace. The work area needs to be free from sources of ignition such as open flames and sparking electrical devices like light switches. So typically we're looking for an area with a radius of 10 feet around the equipment being serviced and should have no source of ignition. If there is any source of ignition, the area must be fan ventilated. Also, we want to ensure the presence of a fire extinguisher, or better yet, bring one with us on every job. And this safe zone also applies around the vacuum pump because it could discharge some residual hydrocarbon gas during evacuation. And this brings us to our second poll question.
Okay, Denny, I'll go ahead and launch that. All right, what is the current maximum charge limit for a natural refrigerant in the United States? Is it A, 155 grams, B, 5.3 ounces, or C, 2 circuits that equal 150 grams? If you would like to go ahead and place your votes, we'll get it counted for you. Okay, I'm going to give it a couple more seconds. So if you haven't voted, please do so. Okay, it looks like majority of people have voted, so I'm going to go ahead and close that out and share the results. The correct answer was B, 5.3 ounces, and 78% of the people attending got that correct, Denny.
Good. Very good. So on to some more general precautions for service. We always want to wear appropriate safety glasses and gloves when working with hydrocarbons and while unbrazing the tubing. This is very important. The work area must be monitored with a hydrocarbon detector and left on located at a low level in the work site because the hydrocarbons are heavier than the air. And the sensor should provide an audible and a visual alarm of hydrocarbons in the air well before there's enough to form a flammable mix, approximately 2% of hydrocarbons in the air by volume. So again, good ventilation is essential to reduce the potential of a flammable mix. And for internal areas, forced ventilation is mandatory by a fan rated for explosive atmospheres. So this is another something that I would recommend investing in, and it's not just good for ventilation, but also for keeping you cool while you're working. So specification of tools and equipment. We only want to use tools and equipment certified for use in hazardous areas with natural refrigerants. Example, the vacuum pump, electrical components and parts. Again, we always want to use the original replacement parts to make sure they are the correct seal type. And now a note on vacuum pumps. Normal vacuum pumps, they can be used if outside the flammable zone, but the on-off switch must not be used because this is usually the only source of ignition in most pumps. But I have to say that I would recommend going ahead and get a hydrocarbon specific pump just to avoid any issues. And use leak detectors rated for combustible gas. If the leak cannot be located with the electronic detector, which will probably be rare, but if it can't, it's best to go ahead and remove the charge, purge and fill with nitrogen, and use a micro leak detector spray. And if you're wearing a manufacturing environment, would always be best to wear an anti-static electricity tag. So, concerning the reclaim machines, we do need to use a recovery machine that's specifically designed for hydrocarbons. Of course, it can also be used with the older refrigerants, HFCs and HCFCs. We need to do this because the standard recovery machines, they can't be used because of the sources of ignition such as switches, high and low pressure controls, and relays. So this is something we need to be very careful about. And also, we want to use hydrocarbon-specific recovery cylinders. We want to make sure the pressure rating and the valve seals are compatible. Now, there are some OEMs that I've noticed are already producing single-use recovery cylinders. The ones that I've seen, they hold just the maximum charge limit, the 5.3 ounces, and they have a filter in them that slowly absorbs the charge. And then you, at the end of the service, after it's had enough time to absorb the charge, you take these filters out and you change them. Of course, you have to change them for every service, but this is a pretty good idea, a pretty good option, I think, because the cylinders are much smaller, much easier to handle, and you're not riding around with large amounts of flammable gas. And always check your local requirements for handling, storage, and transportation of flammable refrigerants. So some more general precautions for service when we're replacing electrical parts inside the cabinet. Example, the lamps, the thermostat, etc. You want to go ahead and sweep the worksite with that hydrocarbon gas detector first. Disconnect the electrical supply. Go ahead and open the doors and keep them open for a few minutes. Then we can go ahead and replace the failed components using original equipment parts, and then close the doors and restart the cabinet. And we want to keep these doors open for a few minutes because, again, the hydrocarbons are heavier than air, so if there's an internal leakage, there could be a high concentration of refrigerant in the bottom of the cabinet, creating that flammable mix. So a little more about leakage. Leakage internal of the cabinet is where we have to be careful from the evaporator to the internal compartment. If it's allowed to accumulate, it can form that flammable mix, and any source of ignition, thermostat, on-off switches, etc., may produce a flame or an explosion. And this is why we want to have all electrical devices encapsulated or fire and explosion proof. Now, external of the cabinet, the possibility of hydrocarbon leakage forming a flammable mix with the air is remote, considering the small charge. Now the built-in systems that you may see that are inside another structure, these are more susceptible to this possibility. So we want to keep that in mind, and when in doubt, ventilate. So one thing that's very good to do before beginning service on a non-running piece of equipment, it's a good idea to perform a failure analysis if we're not already doing this on any other system. Once the location has again been checked for the presence of hydrocarbons and properly ventilated if needed, go ahead and check the refrigeration circuit. We can check for leaks. We'll check the evaporator and condenser fan motors, check for a dirty condenser, temperature sensor failures, thermostat failure, basically a normal system check that we should already be doing on these systems. Also the electrical components. It's a really good idea to go ahead and check those out and make sure they're the correct codes and they're not different than what's listed on the compressor spec sheet. It's going to happen. Somebody's going to change out the components with 3-in-1 start kits that are not sealed, and we want to really be careful of that. So obviously check your start and run capacitor, overload protector, and starting relay. See if they have failed. And if the system runs, take amp draws and observe the pressures. Go ahead and get a good overall idea of what's going on with the system. This is just going to be a procedure that's going to keep you safer when working on a system with natural refrigerants. So just a little bit of information on what you may see with a system that has condenser temperature too low or evaporator temperature too high, suction line temperature too high, or compressor amps too low. These could all point to a refrigerant leak, capillary tube restriction, or the compressor could be internally bypassing. So now on to an overview of a compressor replacement, specifically for an R290 compressor. One other note, hopefully everyone is seeing the trend of good ventilation combined with a small charge helps keep the possibility of a flammable mix at a very safe level. So once we have identified a bad compressor, before beginning the replacement, remember that ventilation and a good combustible gas detector are key in performing a safe hydrocarbon refrigerant compressor change. Go ahead and have the compressor manufacturer spec sheet on hand and verify that the correct compressor is in the system, and be sure to use the new starting components that came with the compressor. So first of all, we want to take that hydrocarbon detector, as we stated earlier, check the work area for the presence of flammable gas, and this is also a quick way of identifying a leak. go ahead and leave the detector in a low area in the work site while working to monitor the site in case we have any leaks develop while we're working. Post a safety placard with no smoking, flammable gas work site, similar to this one, and try to put it in an area where it can be easily seen by anyone approaching the work site. And go ahead and provide ventilation with a fan for explosive atmospheres in internal areas. So, a little bit on the refrigerant removal. Disconnect the cabinet from the main electrical supply. Ground the cabinet if possible to avoid electrostatic sparks. And you can even make up your own ground cable for doing this. Go ahead and access the compressor and install piercing valves. And it's recommended to vent from the high and the low side in case we have a dryer or a cap tube that is clogged. Now, if we do have a safe venting location, go ahead and connect to the valves with a venting tube if we deem that there's a good, safe place to, route that tube to vent. And we don't want to vent into an enclosed space. Do not allow the gas to accumulate in any way. Get after that ventilation fan if we need to. And also place the safety placard next to the venting location if we're remote venting. So if we run that tube out a window somewhere, we definitely want to post a safety placard there so someone walking down the street smoking a cigarette doesn't get a nice little surprise. If safe venting is not available, go ahead and reclaim from the high and the low sides using normal refrigerant reclaim procedures. So, you want to ensure that we're using a hydrocarbon-specific reclaim machine and recovery cylinder. And during the refrigerant recovery, take care of the amount of refrigerant put in the tank and factor in the weight of the tank itself, which is the tare weight. And you'll see TW stamped right on the collar of every tank. That's the empty weight of that tank. So due to the different density of hydrocarbons versus HCFCs and HFCs, it's possible to fill the same cylinder with only 40% of hydrocarbons. So this fact, along with seal compatibility, is why you should have a hydrocarbon-specific recovery cylinder. So basically, if you have a larger cylinder and you're worried about overfilling it, you just need to take the known full capacity of that cylinder of refrigerant along with the tare weight and add those together, and to be sure you are not overfilling the tank. So the tank should only weigh the known full refrigerant weight plus the tare weight, and this will allow for the proper expansion of the gas in the tank. Because with the denser natural refrigerants, they expand at a much higher rate. And this is why again, back to that barbecue tank you got sitting under your grill, it looks like a 50-pound recovery cylinder, but you go get it filled and they only put 20 pounds in it. You feel like you're not getting your money's worth, but this is why. You have to allow for that expansion. So once the charge is removed, go ahead and hook up your nitrogen tank. Purge nitrogen at 50 psi through the system. Get a good purge on that system to get all those hydrocarbons out, displace everything, all that refrigerant out of that system. Always try to cut the compressor out with a tubing cutter. It's just much safer than trying to braze that compressor out. I know a lot of guys do that, but it really can cause issues even with normal systems if you have a little bit of refrigerant trapped in the oil and it decides to come out at the wrong time and spray high pressure oil when you pull that tube apart. I've seen a few flamethrowers, and it's not going to be any better with flammable refrigerant. If for some reason the compressor has to be unbrazed, go ahead and purge nitrogen through the system again at 50 psi. Maybe go ahead and bump that compressor with your hand two or three times to make sure that there's any refrigerant trapped in the oil. It'll come out of there, and the nitrogen can push it out of the system. If you suspect a clogged cap tube or dryer, go ahead and install piercing valves in the discharge and the liquid line to be sure no hydrocarbons are trapped in these lines. And something that works great for this is those piercing pliers. You can quickly pierce a line, invent it, get that hydrocarbon out of there, and go back and use a coupling later to repair it. So go ahead and purge nitrogen at 1 to 2 psi while brazing to displace any residual hydrocarbons and to prevent the black oxide formation inside the tubes that contaminates the system. Now you can buy these special regulators for your nitrogen tank that makes it easy to dial it down to 1 to 2 psi because you can't really hardly do it with a regular regulator. Once we have the old compressor ready, just pull it out, place the new one. Go ahead and purge nitrogen again at 1 to 2 psi and braze on a process tube long enough to be easily accessible but not easily bent over or hit during service. And that's because I don't know if anyone's ever seen one of these Schrader tubes knocked off a system and it vents the entire charge in one quick shot. It's one thing with the old refrigerants, but with a flammable gas, you vent the entire charge in one quick shot. And there's a source of ignition close by, it could cause a little issue. So try to put that in its best location as possible. Then we can go ahead and solder on the suction and discharge tubes on the compressor. Don't forget to install a new filter dryer, of course. And then fill the system with nitrogen to 75 psig and check it for leaks. Once we're ready to charge the system with refrigerant, go ahead and release that nitrogen and get that good vacuum on the system to 500 microns or less. You want to make sure we're doing this to actually get the pressure down on the system enough to boil the water, turn it into water vapor so the pump can pull it out. That's the reason we need to get 500 microns or less on that system. Now, when we get ready to charge it, we always want to make sure that we're using refrigerant that is labeled R290 and not just propane. So the R290 labeling is going to ensure purity because the R290 refrigeration grade is 97% pure. Also, the odorant is removed and there's less moisture. And we want to get that pure R290 because a 1% degradation in purity can lead to a 3 to 6% degradation in system performance. So be sure to purge the charging hose and set up the manifold and hoses so they won't be moved during charging if possible. Go ahead and weigh in the charge listed on the cabinet label, being as precise as possible because of the small charge used with hydrocarbons. And keep our service hoses as short as possible, and after the proper weight is shown on the scale, valve off your manifold so when the system is started, we can meter the charge left over from the charging and the high side hose into the low side. Then we can go ahead and install and connect our new electrical components if they're not already installed, using only the factory original parts. If you get a replacement in Bronco compressors, typically the components are already going to be installed. Go ahead and check the electrical connections and using the spec sheet and verify that the compressor and the unit is properly grounded. Then we can go ahead and reinstall the terminal cover and perform a final leak check before starting the system. So now we're ready to start up and check the repaired cabinet. We can go ahead and start the system and check for proper operation. And then we need to remember to meter in the rest of the charge from the charging and high side hose to the low side. This way the exact amount of refrigerant measured through the scale is put into the system. And any residual refrigerant that's in there is going to be insignificant. We're going to pretty much get exactly the right charge in that system. Then we can go ahead and perform a final inspection of the cabinet and be sure all the guards and access panels are reinstalled. So one final note, if you are uncomfortable with brazing around hydrocarbon refrigerants, consider the lock ring system that uses connectors installed with special crimping pliers. That eliminates the need to braze at all, this kit, and it can also avoid special burn permits in certain work sites. And these kits are sold with all the connectors needed for refrigeration service. So if that's something that you're interested in, you can Google the Vulcan lock ring system. And this brings us to our last poll question.
Okay, Danny, I'll go ahead and launch that. That question is, what is the most important safety procedure when working with natural refrigerants? Is it A, posting a safety/flammable gas placard, B, using a combustible gas meter before and during service, C, cutting system tubes instead of brazing, or D, all of the above? If you guys would go ahead and cast your votes, I will let you know the results momentarily. Okay, I'll give you a few more seconds to place your vote. All right, so it looks like majority of people have voted, so I'm going to go ahead and close that poll out and show the results. And yeah, not tricking them now. That's D, all of the above. And 90% of the people answered correctly. Denny?
Excellent. That's what I wanted to hear. Yep, very important to follow all those procedures, and you know, hopefully everyone's seeing that you know, if you follow all these procedures and with the low charge limit, and you just take care to use that detector, you know, it's an established technology already. The hydrocarbon refrigerants are perfectly safe to use, so that's wonderful. All right, this brings us to the video that you should have gotten a link to through RSES. And if you haven't already watched it, it shows a video of our favorite technicians, Fred and Joe, replacing a R290 propane compressor. And it actually shows it step by step. So if you haven't already watched that, go ahead and go and watch that. And also, go to naturalrefrigerants.info, where you can also find the replacing the compressor video also, but you have a lot more reading about natural refrigerants at this website. So a lot of information that I may not have gone over tonight. So definitely go and do that. And with that, first of all, I want to thank everyone for being here tonight, and I'm going to open it up to any questions that anyone may have.
Okay, so we do have a few questions. Just as a reminder, you can go ahead and ask questions using the GoToWebinar dialog box, and that's on the right-hand side of your screen. One more thing, you can go ahead and download the link to that video that Denny was referring to. It's located in the handout section, which is also in the GoTo dialog box on the right-hand side. The first question we have is, I'm not sure if this makes sense, so help me out a little bit, Denny. How critical is it for air in the system and other non-condensables?
Well, it's just like any other refrigeration system. The air and the non-condensables are going to do the same damage and affect the efficiency of the system just like they are any other system. Maybe even more so because of the small charge. So anything you have in there besides, you know, refrigerant, you're going to affect the efficiency and capacity of that system. Hopefully you vacuumed it at least well enough to where, you know, your new dryer will absorb that residual moisture. Other than that, it's really no different than any other systems. You know, probably more than likely what's going to happen, you're going to get a complaint that the system's just not cooling well anymore, and you're going to have to go in there and do your typical check for moisture with the maybe one of those 5-second test strips, and identify that, and then go ahead and pull the charge, change the dryer, and recharge it, and should be good to go.
Okay, another question. With such a small amount of refrigerant, how would you recommend checking the charge so you don't lose refrigerant each time you hook up?
So they already have systems with really small charges, and most of these, it seems as though the OEMs don't put pressure taps on these systems for that very reason. So if we do have pressure taps, I would say keep your hoses as small as possible. Maybe even use one of those high pressure gauges that don't have a hose. It has nothing but a connection that fits right over the fitting. Or, like I say, if you use really short hoses, you can check the system, see what the pressures are, and then you can valve off your high side hose and then meter the refrigerant that's as much as possible that's in your manifold set back through the low side into the system. Basically, I think it's going to be best to not hook up unless you just absolutely have to. But other than that, just meter what you have in your high side hose and the manifold gauges back into the low side. You're going to get 90–95% of that charge back into that system, and the gas that's still left in your low side hose should be pretty much insignificant.
Okay. Do you know what the LEL of R290 is?
The LEL?
Correct.
Lower explosion limit?
I am not 100% sure on that.
I think that's what that is. I hope that's right. If not, if this person wants to, they can email me if they got my email address at the beginning. But I think that's lower explosion limit, and that's 2% of hydrocarbons in the air by volume. So that's the point where your meter's definitely going to be going off at that point, and it's going to tell you to take action to ventilate that area. But unless you're in a really small enclosed space with only 5.3 ounces, basically 2 or 3 cigarette lighters worth of refrigerant, it's just going to have to be a perfect storm to get it to ignite or cause anything, because it's just going to disperse. And if you have that ventilation fan and you use it in the area, that almost basically takes that possibility down to zero.
Okay. One question says, do OEMs expect to get these new efficiency levels using a cap tube? Would a TEV be a better choice?
TEVs or TXVs always a better choice for efficiency. You're always going to see an efficiency improvement. That's a very good question. I haven't heard any information about that yet. My guess is that if the system is optimized, the piece of equipment, they optimize the gasketing, the walls, the LEDs, the ECM fan motors, I think they can achieve it with a cap tube system. But that's a very good question. I haven't actually heard that yet, but I would really imagine to start seeing more TXVs, because that's just gonna help improve that efficiency that much more. Just like with the air conditioners, we saw the influx of TXVs on all the evaporator cools when they started getting serious about getting the SEER ratings on the air conditioners. So I think we are going to start to see them more. It's actually something I'd like to check into now and see, and it may be too early. The OEMs may need to, do some testing and see if they're able to achieve that efficiency with a cap tube. I think it's a distinct possibility that they can, because there's a lot of different things they can do to improve the efficiency of the equipment.
Okay. Just so everybody knows too, Denny will be receiving these questions after the presentation as well, so he can get back to you as well. The next question is, do you foresee using natural refrigerants in air conditioning equipment, which usually carries over 2 pounds of refrigerant?
That is a great question. That's something that I've thought about as well. I actually think that eventually we may see it. There's a refrigerant called R32 that I believe, I'm not 100% sure, but I believe it's got light flammability, but it's a very high efficiency refrigerant, and I believe that it's going to happen just over time as these become more prevalent and they start mandating higher efficiency levels. I actually believe that they're going to do it. But I think it's going to be the same deal. They're going to have a special charge limit for these types of systems. And again, the manufacturers are going to have to make more drastic changes to be able to achieve that efficiency and reduce that charge as much as possible in these types of systems, because it's more important than ever. When you've got 6-7 pounds of flammable refrigerant in a system. So the one good thing is most of the residential air conditioning condensing units are sitting outside in the wide open space. So then again we have furnaces and evaporators inside crawl spaces and attics. So it's a very good question. I would like to check more into that one as well, but I do think it's going to happen. I really do. There may be some different types of equipment specified, but other than that, I really do think it will happen eventually.
Okay, I have a request for your email address again. Do you mind telling them that?
Not at all. It's Denny, D-E-N-N-Y, .Martin, M-A-R-T-I-N, @embraco.com, and it's E-M-B-R-A-C-O.
And another question was the last website you gave, which was the Natural Refrigerants website. Can you also repeat that?
Yes, it's Natural Refrigerants. Actually, I think I have it. Can I go to the other screen that has it?
Yeah, go ahead.
Yeah, right there. Naturalrefrigerants.info. And that's all you need to do to go to that site. And then you can go to different tabs to see all kinds of different information. And I actually think the compressor changeout video, I think for some reason I think it's in the tab Y. Or I think so, but it's not that huge of a website. Should be hard to find, but yep, naturalrefrigerants.info, and that has a lot of good reading on it.
Okay. Do regular leak detectors pick up R290?
Like a regular, no. I would say no. I don't think that's something that I would like to check into as well, but I don't think they currently do. And that's some research that technicians should do, because I'm not even sure that a regular combustible gas detector, like for natural gas, picks up hydrocarbons. I'm not sure about that. So I would do some research on that and see if a regular combustible leak detector will pick that up. If not, we'll have to get hydrocarbon specific. But yeah, contact the the Richies and the all the other manufacturers, Infocon and all them. I would do some research and talk to some people about that, because a lot of this stuff is still so new. There's still a lot to learn for everybody. So that's definitely something to do some research on.
Okay, there are so many good questions. I'm not going to get to all of them, but please know I will submit all your questions to Denny after the presentation, and hopefully either I will get back to you with his answers or he will respond direct.
Yeah, I usually respond direct, and I'll make sure that that all those questions get answered either by myself or we have a great applications engineer, John Prawl, on staff as well. That's very up on this on the natural refrigerants, and we'll make sure that all those questions get answered.
Okay, fantastic. I'm going to ask one more, and then I'm probably going to close up. Procedures for plugging in the equipment. Somebody's asking what that is.
Basically, after you followed all your procedures you know, it depends on what you're doing. If you're changing parts, if you left the cabinet doors open for a little while to vent the equipment, you changed your parts. You know, you've closed everything back up. You should be ready to plug that piece of equipment back in. Now, if I was doing service work, if I was changing a compressor, or I was actually breaking into the refrigeration circuit, once I got everything repaired and reinstalled, I would definitely go over the system again and perform a final leak check, and go ahead and check all that and make sure that the compressor and the unit is properly grounded, and then that unit should be perfectly ready to plug back in.
Okay, I'm going to ask one more question.
Sure.
Will people be able to access your slides? I've had a couple of requests for that.
Now, I know this goes up on your website, Lori, right? But
correct, the webinar itself, but not the PowerPoint.
Yeah. Now, we get the PowerPoint, or we get the. Can we send anyone the link to the presentation, or?
Absolutely.
Okay, and then they can access it that way?
Yes.
Okay. Yeah, and otherwise, I don't think I have a problem handing out the slides. If they want to contact me directly, if they're interested in one slide specifically, I don't think I have a problem, you know, providing a copy of that slide.
Okay. All right, I'm going to go ahead and take the screen back here. And I'm going to go ahead and close up. Well, thank you everyone for attending this webinar, and of course thank you Denny for taking the time to present this topic. And I'd like to especially thank Embraco for sponsoring this webinar. For those of you who would like to view the presentation at a later date, which we kind of just discussed, you'll be able to do so the next few days on the member-only section of rscs.org, and I will show you how to get to that right now. So if you go to www.rscs.org, enter your username and password right here, and select Login. You're going to go to the My RSCS homepage underneath the Logout button, and then select Webinars in the left-hand side of the screen. It will show you all of the upcoming webinars that you can register for, and then all of our archive sessions. Also, webinar attendees from tonight's live event will receive a certificate for completing 1 hour of continuing education. Those will be distributed within 7 to 10 business days. If you have any questions, you can email me directly at webinars@rscs.org. Again, that's webinars@rscs.org. Thank you again, everyone, and have a great night. This webinar is now concluded.